Okay, good morning. Welcome to OOP, the Pokemon Journey. This is a beginner's level session, kind of talking about the concepts of object-oriented programming. I hope you'll enjoy it. My name is Fatima. My Drupal.org username and Twitter handle is Sugar Overflow. I work for Digital Echidna. We're a digital services agency in London, Canada. I'm also on the leadership team for Drupal Diversity and Inclusion, which is a working group in the community to kind of improve the conversations around making it a more inclusive and welcoming space. Today I'm going to be talking about OOP, object-oriented programming. It's a way of organizing our code that makes it a little bit more modular, reusable, and flexible. What this means is instead of writing code for multiple things, we can kind of containerize our code and write one code base and then extend it and use it in many different ways. And that sort of helps us not have to write the same thing over and over again. The way we're going to do this session is we're going to have a story, we're going to go on a Pokemon journey, and throughout that journey we're going to map some journey concepts and story ideas into concepts that then translate to OOP. I've also added a bit where we kind of look at an example in Drupal core so that you have something to go back to when you think about these concepts. So when we start our Pokemon journey, the first thing we do is we visit Professor Oak at the gym, and we choose our starter Pokemon. And for this class, we're going to use Pikachu. And so we started our journey with Pikachu, so we want to learn a little bit about what Pikachu is. And we know that Pikachu is a type electric Pokemon, and it also has an attack called Thunderbolt. And so kind of what we have here is a model for what a Pokemon would be. It has a name, a type, and an attack. And when we think about how we can model this in code, OOP provides us something called classes. I think of classes like blueprints. They're kind of fundamental sort of building blocks for what you're trying to make. Classes have two main parts to them. One is a property, which you can think of as a data point. In our Pikachu example, a data point would be the name of the Pokemon or the type of the Pokemon. Another part of classes is methods. You can also think of them as functions, and these are specific to the class. For example, Pokemon have the ability to attack, and in Pikachu's case, that attack is a Thunderbolt. So that would be the method for the Pikachu class. I'm gonna take a breath. Cool. So now we're gonna go ahead and look at the code for our Pokemon class. And in this, you'll see that when you're creating a class in PHP, you have something called the class keyword, and then you have the name of the class. The first two things underneath class Pokemon are what we were calling the properties or the data points of the class. So for Pokemon, we have a public variable called name and a public variable called type. And we also have a method, which is the public function attack. And for now, it just does something and returns an attack. Public in this case is what we call visibility in PHP, and that kind of allows other classes to use or access those methods. So there's also protected and private. So this is what a very bare bones class would look like. And now that we have a class and we have the ability to have a name and a type, we have to think about, but how do I create a Pokemon? And in OOP, we call that creating an object of this class, or instantiating the class. And to do that, PHP gives us this magic method called a constructor, which is written like __ construct. And a constructor basically allows us to create the object that we're building in that class. So in this case, it would allow us to create a Pokemon. You can pass parameters to a constructor. So those are things that you will need to give to the object when you're creating it. So in this case, whenever we create something of class Pokemon, we're always going to need to pass it a name and a type. And then inside the constructor, we have some syntax for the this variable, which basically refers to the class that you're in. So here we're passing in a name and a type, and we're giving the class that name and type. You don't have to take notes. There'll be a link to the slides at the end. I feel bad when people are typing because I'm talking too fast. And then now that we have a constructor, we can go ahead and create a Pokemon object, and we would do that like this. So if we're creating a variable Pikachu, we'll use the new keyword to create an instantiation of the class. Pokemon is the name of the class. The name we're giving is Pikachu. The type we're giving is electric. And since there is an attack function in this class, this is how we can call Pikachu's attack function. This is very pseudocode. And then we can look at an example of a class in Drupal core. The one that I picked was the translatable markup class, which extends formatable markup. We'll talk a little bit more about extends later. And you can see in this they have a constructor and a property called translation, and basically they set that property when this class is created. It's kind of confusing. Cool. Go back to our story. So we're going on our Pokemon journey, and Pikachu and I come across a wild Pokemon in the grass. And we capture this Pokemon, and it turns out it's an Oddish. And now we have to analyze our Pokemon to kind of understand what's the difference between a Pikachu and an Oddish, and how can we model that difference in our code. So what we have here is an electric type Pokemon with an attack of Thunderbolt, and a grass type Pokemon with an attack called Poison Fire. And so now we're looking at this and we're like, hey, we can't just use one generic Pokemon class anymore, because now we have different types of Pokemon. So how can we model that in code? And for that, OOP provides us something fancy called inheritance. And I like to think about inheritance as sharing, because there's a parent class, which in our case is the Pokemon class, and then there are child classes which can inherit from the parent class and take all the functionality, but also override the things that they want to change. In my notes it says, you can also think of inheritance as a tree, and the parent class is kind of the stump of the tree and the branches are the child class. So you have a base functionality, and then you have things that can kind of grow from there. Cool. Now let's look at our parent Pokemon class, which is this. I kind of took out some of the properties. So we're going to focus on the attack function that we have in our parent class. We can also call this a base class. And then we're going to use the extends keyword to create an electric Pokemon class. So that extends keyword tells us that this electric Pokemon class is inheriting from the parent Pokemon class. And then within that, in the public function attack, we've overridden what was just an attack with the electric attack. We can go one step forward and make a Pikachu class that now extends from the electric Pokemon class, which extends from the parent Pokemon class. And in this one, we can get even more specific in the attack function and return the Thunderbolt attack, which is very specific to the Pikachu class. So basically, when you have a parent class and child classes, you can choose to override whatever you need to override. And that gives you the flexibility to sort of have different types of classes, but they all share one kind of base functionality. And then we can look at an example of inheritance in Drupal. This is actually something I used on a project a few weeks ago. So there's a widget interface that has a form element function, and then there's an abstract class. Abstract basically is kind of like a class that has empty functions that you then have to implement. You can't create an instantiation or an object of an abstract class, but you can extend from it and use the functionality to create other classes. So in this case, the last part, the range widget, extends the widget base, which implements the widget interface, which has that form element function. So you can kind of see how it kind of trickles down to the class that you're using for the inheritance. And then in the range widget, it's got something interesting that it doesn't have in the original interface, which is the from and to part of the form, because it's doing a range. So it's for me, it was a good example of how it's overriding something that exists in a parent class that it's using. Give me a second, I'm gonna drink water. Cool. We're going to go on with our journey, and of course, in every Pokemon world, you have to do gym battles. And this turns out to be our first gym battle, and we don't really do so well, because we're just like, Pikachu, go! And we don't really strategize or think about how we're going to win this battle. And that makes us realize maybe we need to think a little bit more about the sort of strengths and weaknesses of our Pokemon. And that's something that we're going to have to model in our class now. So if we compare our Pokemon, we have Pikachu. Sorry, excuse me. I messed that up. So Pikachu, which has a strength against water-type Pokemon and a weakness against ground-type Pokemon, and Oddish, which has a strength against water but a weakness against fire. So we can sort of use these strengths and weaknesses to choose which Pokemon we send into battle. And in order to model that into our class, we're going to use another magic method that PHP provides, and that's the get and set methods, or we can also refer to them as the getters and setters of a class. So, for example, in our parent Pokemon class, we can write the get weakness function, which returns the weakness of the Pokemon, and the set strength function. The first one is an example of a getter, and the second one is an example of a setter. And with a setter, you can actually set the strength for the Pokemon. And you'll see these in many different ways, like get parameter, set parameter. It's a very common way to access or to add things to a class when other things in the class are protected or private. So this is our parent class. If we go down into our sort of electric Pokemon class that's inheriting from our parent class, we can actually give it parameters that have certain properties. So the strength for an electric Pokemon is grass. So when you do get strength, when you call get strength on your electric Pokemon, it'll return the actual strength type that that Pokemon has. And of course, when you create the constructor, you can pass it a strength and a weakness if that's how you want to create your Pokemon. And then if we look at getters and setters in Drupal core, one of the ones that I tend to use a lot, it comes from the route match class, which implements the route match interface, and it has this function called get parameters. And what route match lets you do is get the parameters that are in the URL, which can be really useful if you're doing some contextual filtering. So this'll kind of, if you call the service and you do get parameters, it'll give you everything that's there. So this, I think, was a kind of simple to understand example of a getter in a Drupal class. Cool. Now that we can have getters and setters in our class, we're going to go back to our Pokemon object and see how we can use them. Oh. We're going to take a break. Okay, oh, it's back. We're going to see how we can use them in our Pokemon object. And so in this case, we'll create a new Pokemon called Pikachu, give it a name and a type. And that probably... Oh. Right, okay. So we could create a new Pokemon Pikachu with a name and a type, and then we can call the get strength method to get the strength type of that Pokemon. But we can also create an electric Pokemon called Pikachu and get the strength. And so here we hit this dilemma where we're like, should we really be able to create generic Pokemon types? Because now that we have electric Pokemon or water Pokemon extending from the Pokemon base class, do we really want a generic base class to be instantiated? Because that wouldn't make as much sense anymore. So OOP and PHP allow us to create a base class, but make it so that it can't have objects of that class. And that's something fancy called interfaces. So I think of interfaces like contracts. All the methods are public, but they don't have any functionality inside them. Basically, any class that implements an interface has to put the functionality into those methods. This works really well for us for the Pokemon interface, because we'll have all the functions that we need in a Pokemon class, like electric Pokemon, but we don't have to use this as a generic Pokemon. So this is an example of our Pokemon interface. I put some getters and setters in there, and also our attack function. Generally, interfaces are cool because you can put all of these function calls in them, and then when you implement them, you can put in all the body, and that gives you a lot of flexibility. So let's look at implementing this Pokemon interface with our electric Pokemon. We start out by using the implements keyword. So class electric Pokemon implements the Pokemon interface, or class Pikachu extends electric Pokemon, and since it's extending a class that's implementing an interface, it's inheriting all of the methods that were in that interface. And then we can look at what that class would look like. So these are the functions that are now coming from the interface, and we've basically given them some functionality as pseudocode. So for the get strength method that's in the interface, we're returning water, and for the get weakness, we're returning grass. This isn't entirely correct because the interface, as you saw, did have a lot of functions, and so in order for this class to be valid, we'd have to implement all of them, but this is just 2 examples. Cool. And then a good example that I think in Drupal core for interfaces is the form interface. And the form interface has this function called getFormID. So the abstract class form base, which is basically kind of like the base for when you create custom forms, implements that form interface. And one example of a form that extends form base is the user login form. And in that class, you'll see the getFormID function actually being implemented and returning the ID of the user login form. So this is a good example of how the interface defines a function that the class implements, and then the class that extends from that class has to put something in the function body. Cool. Back to our story. So we've been traveling quite a lot. We've won a lot of battles, made a lot of friends, and one of our friends on our journeys actually gave us a water stone, which allowed one of our Pokemon to evolve. And so that's new to us. Now we have to build some kind of evolution functionality into our classes. And in order to do that, we're going to use something that PHP provides called traits. And I think of traits as code snippets. It's a way to reuse code and kind of like code copy pasta, but you don't have to inherit from it. You can't create an instance of the trait. So there isn't like a trait object that you can create. It's kind of similar to a class, but it's a little bit more lightweight. And for our case, we're going to create a Pokemon evolution trait, which will look something like this. For creating traits, we use the trait keyword and then the name of the trait. And in this particular trait, we have the evolves to function that'll tell you which Pokemon is in the next stage of evolution. In order to use this trait in our Polyworld class, which extends our water Pokemon class, you use the use keyword and the name of the trait, which I got wrong. That down here should say Pokemon evolution trait, so it matches the name of the class on the trait. Sorry, the name of the trait. And in that trait, in this class, we have an evolve function, and within that evolve function, we're actually using the function that we're inheriting from the Poke evolution trait. Right here. Surprise! I thought that was cool. The traits are a great way of, like, if you have a small piece of functionality that you want to include in your class or plugin. A good example of traits in Drupal core is the string translation trait, which you've probably used before. It's that T function. And in the abstract class plugin base, they actually just use string translation trait. So whatever you create custom plugins, you're extending plugin base, and so you get that string translation trait with all of your plugins because it's in the abstract class. And congrats! You won your first gym battle, so you got your first badge. This is a badge that actually kind of looked like a Drupal drop, so we didn't have to do any Photoshop on that. So that was pretty cool. So now that you've won your first badge, now we're thinking about, oh, there needs to be a badge system. There has to be a system of how do I earn badges? What are badges? What is this new thing that we need to now implement in our classes? And the way I think about the badge system is that it's a functionality that can change because different badges will have different types of requirements on how to earn them. And so something that OOP provides us is called plugins. And I think of plugins as functional Lego blocks. So they're like pieces of functionality that you can plug into your classes and use. There are many different types of plugins. I discovered this while making my slides on the road. Generally, there's a type of plugin that we use commonly, like for blocks and views, and that's called the annotated plugins, and that's what most of us are familiar with. There's also YAML plugins, which are menus, routes, or services, and there are other types of plugins like hook plugins, which are things that moved over from D7, and discovery and static plugins as well. But for now, we're just going to focus on annotated plugins. Plugins are kind of things that have different behavior, but they have a common interface, and what that means is that they all kind of are structured the same way, but they can do many different things. So you can have like 5 plugins and they kind of have the same structure, but they all have different functionality. Let's look at what a Pokemon plugin for badge system would look like. And in order to do this, we're going to make some assumptions. When you're making a custom plugin, you have to do a couple of things. You have to create the annotation definition. You have to create a plugin manager. So we're going to assume that we've done all of the above. And we're up to the step where we're creating the plugin base for our custom plugin. And we're going to call it the Poke Badge plugin base. And what this does is implements a Poke plugin interface. Let's say we've also created that. And what this has is a abstract function called isTheBadgeEarned. And so, when we create that custom plugin called Drupal badge, we extend the plugin base that we created that comes with all of the other things like the interface, the plugin manager, and we basically implement that badge earned function. Generally, it's not that complicated because I feel like the logic for wanting to create a custom plugin, you might never need to, maybe in very rare cases, because there are so many plugin types that have so many boilerplate code. There's so much boilerplate plugin types in core that you won't ever have to create your own plugin base. You'll just extend one of them and implement the functionality that you need. But in the case of Pokemon, I couldn't really find a plugin base that I could extend, so I had to do the assumptions of creating one and creating the manager to go with it. If we look at a plugin in Drupal, again, this is an annotated plugin. It's block-based, and block-based basically gives us all the function, or not all the functionality, but some functionality that we can use to create custom blocks. In block-based, there's a build function which returns the build array of the block. So when you create a custom block, you override that function if you want to add things to your custom block that the parent doesn't have. Like maybe you want to add a custom array of things that you want to display on your block. And so you would do that in your build function. Cool. So now that you've been winning badges and you're doing battle, now you want to be the very best. So that means you gotta go compete in tournaments. But before you join a tournament, you need to submit your trainer profile. And in order to submit your trainer profile, you need to have all the stats of your Pokemon's wins and losses. And let's just say that all those wins and losses have been stored in a database. And now we want to retrieve them. And in order to retrieve them in our classes, we're gonna use something special that OOP provides called services. Services are like swappable operations. I think of them as the functionality is the same, but the code implementation can be different. So you could have 2 or 3 services that do the same thing for you, like retrieving data or sending an email, but they can all do it in different ways. Services are generally globally available, so you can use them in your classes, and there's usually an interface that comes with it. So it'll be a service that's implementing an interface that has the base functionality for that service. So if we look at creating our Pokemon service, we'll call it class PokeData service because we're going to get our data for our Pokemon, implementing a PokeData interface. And it has a function called getYearlyStats, which takes a Pokemon as a parameter and a year. And a year. And then it returns like an array of data for that particular Pokemon. We're going to make the assumption that that PokeData interface exists for this service. Now, we have a service that gets us our yearly stats, so how do we use it? To do that, we call our Pokemon service. First, we create our Pokemon, and then we load our service. And here we're calling it a PokeData helper, and the sort of syntax for loading a service globally anywhere in Drupal is you do the /Drupal with the 2 colons, and then the machine name of the service. So that's Pokemon.PokeData service. And to actually use it, we can do the PokeData helper with the arrow and call the method that's in the service and pass it the parameters that it needs to return the data for that particular Pokemon. Does this make sense? I realized when we were going into the more sort of like plugins and services and dependency injection that like Pokemon may not be an easy way to explain things anymore, because when you get so deep into the OOP, it's kind of like you have all these assumptions that you have to make in order to understand the one concept. So that was a bit of a struggle.
Yeah, there are plenty of variables.
Yeah, so it starts to get exponentially complicated. It's not actually that complicated now. So we'll look at services in Drupal. Drupal core provides a lot of services, and you can check them out in the core services YAML file. One of the services that I like to use or have to use a lot is the current user service, which comes from the account proxy class. And basically that allows you to load who the current user is. And to do that in like a module or a class globally, you would use the line at the bottom where you're loading the user class and then using the load function and then calling the current user global service to load the user. That makes sense? That's kind of like a double. So this part is loading the service, and this part is calling the load method from the user class. I need like a clicker pointer. And services in Drupal are swappable. This was a little hard to show in the Pokemon example, but one example of a service that you can swap out would be the email validator service, which is used in the contact form edit form to check if the recipient is valid. So this particular email validator service comes from the Igulias class, but essentially you could use any other email validator service and put it in place of the call for the contact edit form. So same functionality, different code. Swappable. And then when possible, you should inject your services with dependency injection, and that's just kind of preferred. To do that, you would pass that service as an argument to the constructor, or you would use a setter method. And we'll look at what that looks like in our Pokemon service. So here you'll see that we have a protected PokeData service variable in our electric Pokemon class. And in our constructor, we have a PokeData interface PokeData service variable. And we're basically setting it to the property that we have. And you'll see that we have a use statement to kind of load that PokeData service into our class. And when you do dependency injection in a class, you need two things. You need one, the constructor to load that item and to initialize it, and two, the create function to create the container to load the service into. So here you would do the name of the service in the return statement, and here you would load it into a variable in your class so that later on in your functionality you can use this variable to call the functions that are in that service. I see people nodding, so I think it makes sense. Does that make sense? It's a little rushed.
It does. It's a little kind of
rough,
heady, but yeah. You're calling from one to another.
Yeah. So I'm inside my electric Okay, so I'm inside my electric Pokemon class, and I want to use functionality that's only available in my PokeData service. So the first thing I would do is I would put the use statement for that service to load it into the class. Then I'd create a parameter to use that service inside my class. So I'll call that PokeData service. Then I'll create my constructor, and in my constructor I'm going to pass the PokeData service, because every time I create an electric Pokemon, I want to make sure that that service is there as well, so that I can load it and use it. And then I'll create the create function to create the container for the service to load the service into the container. Whenever I think of it when we're doing work, I think, oh, I have a service that I want to use, and I'm inside a custom block. Do I have a constructor? That's my first question. And if I don't, then I make a constructor, I pass in the service, and then I look at the block and I'm like, I guess if I didn't have a constructor, I probably won't have a create function. So then I have to implement the container interface, write the create function, and put the service into the container. So maybe this will help it make more sense. I have a custom form. I'm extending form base. I should also be implementing the container interface. Don't know how I missed that. I have an account variable and a constructor into which I'm passing the account interface to use the account object and to set it to the variable inside my class. Then I have the create function in which I'm calling the current user service to put it into the container so that I can use it when I'm looking for, like, trying to call methods from the account interface.
Getting from the container?
Getting from the container? Can you explain?
Because all of your services are in the service container. So with that create method, the create method is receiving the container, and then in your function body of your create, you're grabbing whatever services from the container and then returning them so that they can be passed to the constructor.
Okay, I'm going to repeat that so that's on the thing. So we're getting the container in the parameters, and then over here we're getting the service from that service container so that we can pass it into our constructor and use it in our class.
And so the container is something that has all of the services available to you kind of in it that you can just grab by that machine, like you said earlier.
Thank you. And that's all I have. There's a lot out there in terms of OOP, and as you do more work in the backend, you'll discover new and interesting things. This was meant to kind of be a foundation for the basics so that you have some kind of examples to refer to that are not so technical, so you can kind of map out the concepts a little easier. That's also how I first learned programming. So I hope that helps. Thank you. You can reach me at Trigger Overflow on Dio or Twitter, and the slides are at this link. Questions? Hi.
What's your favorite Pokemon game?
Pokemon game? I actually haven't played any of them. So when I first learned OP, it was for C++, and my professor used this example of warriors and nobles. And we had to create this medieval environment where we had warrior class and noble class, and then they did battle. And so when I first wanted to give this presentation, I talked to a friend and I was like, hey, what do you think of this analogy? And he was like, what? And I was like, oh, I have to find something simpler. And so I did a lot of research, and people use animals, and then they do cat, dog, have different, properties, or they do vehicles, and they'll do train and car. And I was like, what can I use that's both exciting, a lot of people would know about it, and would be interesting? And somehow I just thought of Pokemon. So I haven't actually played the games. I do play Pokemon Go. That counts? Okay, that's my favorite game. Any other questions? No, they're just smiling.
Any other places to get Drupal OOP resources?
The API docs are really good. They have chunks of pages for that. API.drupal.org. Drupal as Me has a lot of written documentation for OP, plugins, services. They have a really great example about custom plugins called the Ice Cream Factory. They have a whole page where they talk about an ice cream factory and then creating plugins for flavors and things. So that is an interesting read. Any other questions? Cool. Well, thanks for coming.